All right, let's just dive right into this explainer. We're going to strip away all that extra noise and really focus on the pure physics of why our world feels, well, a lot less stable today. I mean, we hear about climate change constantly, right? But so often it's totally buried in political debates or just super confusing statistics. So today we're taking a step back. We're going to look at this strictly from first principles. We're going to build a solid foundational understanding of what climate change actually is as a physical system and exactly why the year 2026 represents such a critical moment in how we experience it.
So let's start with the big question. Why does climate change feel so unbelievably urgent right now, like today? Well, it's because the future isn't just some abstract idea anymore, is it? It's arriving rapidly, right into our normal everyday routines. You're definitely not imagining things. The system is no longer behaving like some distant trend on a graph you can just ignore. It's showing up as really immediate disruptions. We're talking hotter seasons, way stronger weather extremes, and honestly, much higher costs when things break down. The urgency we're all feeling, that's precisely because the evidence has finally gotten close enough to our everyday lives that denial is just getting way too hard to sustain.
Section 1. The strain on the bridge.
Okay, to really wrap our heads around this urgency, we have to look at how damage actually builds up in a system over time. And it really helps to think about how physical structures bear weight. Imagine our climate is like a bridge. Now, this bridge has been carrying normal traffic for years, and at first, everything seems perfectly fine. But then, tiny little cracks begin to appear. Now, one crack? That's easy to ignore, but as more and more weight keeps passing over it, those warning signs become absolutely impossible to dismiss. Climate change works the exact same way. It's not one sudden, crazy disaster out of nowhere. It's this quiet, growing accumulation of strain. What's really changed recently is our exposure to it. More of us live in places where extreme heat or sudden flooding actually matters. This accumulating strain is exactly what makes everyday life, like suddenly having to pay massive repair bills or dealing with crop failures, feel so incredibly fragile. This slow shift is literally reshaping our ordinary decisions.
Moving on to Section 2. Earth's simple energy balance.
Let's look at the actual engine driving the whole shebang. The absolute crucial takeaway here is that climate change is simply what happens when Earth's energy balance is thrown out of whack for a long time. See, the Earth is constantly trying to balance incoming energy from the sun with outgoing energy bouncing back into space. Think of it like a house on a sunny day. Sunlight pours through the windows and warms up the rooms. Now, if the windows are open, that heat escapes pretty easily. But if the house suddenly becomes way better at trapping heat, like if someone sealed all the windows shut, the inside is obviously going to get warmer. The temperature only changes when those two flows, the incoming sunlight and the outgoing heat, stop matching up. That's an energy imbalance. Now, this is huge. This busts probably the biggest misconception out there. Greenhouse gases, things like carbon dioxide and methane, they don't act like a second sun. There's no magic involved. They don't just create heat out of thin air. Instead, they act exactly like a really thick blanket on a cold night. Your body is already generating heat, right? The blanket just slows down how fast that heat escapes into the cold room. It's the same with our planet. The atmosphere has basically become a little bit too good at holding onto the heat the Earth is naturally trying to radiate back out into space. The real problem is all those extra greenhouse gases we've added on top of the natural background levels. That's what's tilting the balance. This right here is basically your complete first principles cheat sheet for planetary physics. Look at how perfectly logical this flow is. Sunlight comes in, heat leaves. If more energy comes in than goes out, boom, we have an imbalance. Greenhouse gases are what slow down that heat loss. And this is where it gets wild. The system reacts with feedbacks that actually reinforce the warming. Ultimately, different parts of the planet end up reacting in totally different ways. Once you really see this logical progression, you stop treating climate change like some vague political slogan, and you start seeing it for what it is, a totally predictable physical machine.
Section 3. System memory and feedback. So the Earth definitely isn't a simple machine that just gets warm and then suddenly stops. We really have to look at the motion of the system because it actually has a really profound memory and a massively delayed reaction time. Think of it like a giant water tank with a really noisy tap. If you turn that tap on full blast, the water level doesn't just instantly teleport to the top, right? It rises gradually. And if you turn the tap down, the level doesn't instantly drop either. The system adjusts slowly. Our oceans act just like that tank, absorbing an absolutely enormous amount of heat. And that's exactly why the worst impacts show up long after the energy has quietly built up. This lag time is literally why the problem can feel kind of distant or less real in the moment. The initial cause and the eventual effect are just separated by time.
And, just like a pot of water on a stove doesn't heat up perfectly evenly everywhere at the exact same instant, the Earth doesn't warm evenly either. Global warming shifts local vulnerabilities in very different ways. This is how the dry physics translates into our messy reality. One single scientific issue turns into this massive, cascading chain of linked societal stresses. So a farmer dealing with dry soil, a doctor treating heat stroke, a city planner staring at flooded storm drains, and a power grid manager trying to keep the lights on during a heat wave. They are all facing the exact same underlying shift in the system. They're just experiencing it through their own specific local vulnerabilities. Which brings us to Section 4, From Events to Systems.
Now, this requires a massive, absolute paradigm shift in how we process the world around us. We've got to upgrade our mindset. We have to stop just asking about isolated, random weather events and start figuring out how the entire underlying system has been totally rewritten. See, event thinking asks, hey, did this specific storm happen today? But system thinking asks the much deeper question. Wait, how has the whole system changed so that storms exactly like this one are now way more severe or common? Climate change isn't just bad weather. It's the gradual, total rewriting of the background rules that shape our weather, our water, and our land.
Finally, Section 5, Making Sense of 2026. So, what is the deal with 2026? Why does this specific year matter so much in the grand timeline of planetary shifts? Well, the year 2026 itself isn't magic, but it marks a really stark turning point where that delay we talked about, the lag between the original cause and the everyday consequences, becomes entirely impossible to ignore. Enough time has passed that the energy imbalance, the system feedbacks, and all those local stresses are suddenly visible all at once. That strain on the bridge? Yeah, it's now visibly, undeniably altering how we buy our food, how we manage our water, how we build our roads, and frankly, how we manage our own personal bank accounts. If you take away literally just one thing from this explainer, let it be this incredibly empowering thought. You absolutely do not need to memorize a giant list of environmental statistics to understand our changing world. You really just need to understand the system. Small imbalances accumulate, heat sticks around, and local effects eventually show up right on your doorstep. So now that you grasp these fundamental mechanics, the lag, the basic energy balance, the accumulating strain, ask yourself, what are you actually going to see the next time a severe storm rolls into your city? And more importantly, how are you going to prepare for a system that is clearly no longer playing by the old rules?